Why would the same organizations building permanent bases beyond Earth also spend billions protecting the planet they already have? At first, those looked like two completely different stories. One was about exploration. The other was about survival. But the more I looked, the harder they became to separate. The same agencies kept appearing. The same long-term planning. The same willingness to invest in projects that might not fully matter for decades. Somehow. All of it seemed to be pointing toward the same idea. I just couldn't see what it was yet. Whatever connected them. It completely changed the way I thought about space. Because I eventually realized this was never about reaching another world. It was about why one world isn't enough. When people picture the moon, they usually imagine a mission. A rocket launches, astronauts land, they spend a few days collecting samples, then they come home. That's how we've thought about space exploration for decades. But Artemis doesn't look like that. The more I read through the program, the more one detail kept appearing. Every mission existed to make the next one possible, not to repeat a historic achievement, to assemble something that could remain. A station in lunar orbit, surface habitats, communications, power, piece by piece. Artemis wasn't being designed as a destination. It was being designed as infrastructure. And it isn't being built with the expectation that people will visit once and leave. It's being built so people can keep coming back. Again and again. For years. Maybe much longer. That was the moment I realized I was looking at something very different from the space programs I grew up learning about. The Apollo program was built to reach the moon. Artemis is being built to remain there. Those aren't the same objective. Then I noticed something even stranger. The United States isn't building this alone. Europe, Japan, Canada, multiple partners are investing in the same long-term architecture. Not for a single historic mission. For a capability that's expected to exist long after the first crews arrive. And that's where the old explanations started to fall apart. Curiosity can explain why you go somewhere once. It doesn't fully explain why you spend decades building the ability to stay. So if exploration isn't the whole story, what is? At that point, I became convinced there had to be another reason. Maybe someone knew about a danger the rest of us didn't. An asteroid. A climate scenario, something serious enough to justify building beyond Earth. The evidence seemed like it should point there. Instead, it kept pointing somewhere far less dramatic. Take NASA's planetary defense program. Its entire purpose is to prepare for an asteroid impact. Not because one is expected next year, or even next century. In fact, NASA says there are no known large asteroids on a collision course with Earth in the next 100 years. So why keep investing? Why continue improving detection systems, running impact simulations, testing technologies like DART, and updating long-term response plans? NASA isn't building those systems because they expect an impact next year. They keep building them despite believing one isn't expected. That was the detail I couldn't ignore. The investment wasn't following a prediction. It was following uncertainty itself. Most of us prepare when we know something is coming. Long-term planners prepare because they know they can't know. That turns out to be a very different way of thinking, which raised an even bigger question. If nobody knows what the future threat is, why prepare so aggressively anyway? That question led me somewhere I wasn't expecting. The answer had almost nothing to do with space. It had everything to do with how we manage risk. Think about the systems we trust most. Airliners don't rely on a single flight computer. Critical data isn't stored in just one place. Different technologies. The same philosophy, when failure would be catastrophic. You don't eliminate every risk. You eliminate the single point whose failure would end everything. Then I imagined everything humanity has ever built. Every library preserving centuries of knowledge. Every hospital. Every city glowing at night. Every family. Every scientific discovery. All of it resting on the same thin layer of life wrapped around one planet. From an engineering perspective, that's a single point of failure. I wasn't looking at a new way of exploring space anymore. I was looking at an old engineering principle applied on the biggest scale imaginable. And suddenly, the question changed. If humanity is treating Earth as a single point of failure, then what exactly is it trying to protect? The more I followed that idea, the more often the same pattern appeared. Different institutions, different technologies, different missions, yet they all seemed to be solving the same underlying problem. That's when I stopped seeing isolated space projects. I started seeing something much larger. Because building resilience isn't something you solve with a single technology. It takes systems. The same is true for planetary defense. It's not one telescope watching the sky. It's a network. Space agencies, governments, emergency planners, international organizations. They're all connected because no single institution can protect an entire planet on its own. Then I realized the moon was being approached the same way. Not as a place to visit. As another system, none of it works in isolation. Launch vehicles need communications. Habitats need power. Surface crews depend on everything above them. The individual pieces matter far less than the system they create together. Continuity. That's what caught my attention. The conversation was never just about getting people farther from Earth. It was about making sure human activity could continue, even when one part of the system failed. And that's a very different objective. Once you stop thinking about individual missions and start thinking about civilization itself, a much bigger question begins to emerge. How do you reduce humanity's dependence on a single world? Looking back, all of those examples suddenly lined up. They weren't really describing rockets. They were describing a design philosophy. I'd been thinking about space as expansion. The people planning decades ahead seemed to be thinking about something else entirely. Redundancy. Engineers call that redundancy. If one system fails, another keeps the whole network alive. The objective isn't perfection. It's survival through failure. Then one question kept bothering me. If engineers refuse to accept a single point of failure in an aircraft, why would we accept one for civilization? The more I thought about it, the harder that assumption became to defend. Because right now, humanity has exactly one biosphere. One planet capable of supporting every human being, every archive of knowledge, every culture, every economy, everything we've ever built. It's all concentrated in one place. From an engineering perspective, that's an extraordinary amount of trust to place in a single world. Maybe that's why the conversation isn't really about reaching another planet. Maybe it's about making sure civilization is never defined by only one. The surprising part is where that way of thinking leads. If becoming multiplanetary were really about leaving Earth behind, you'd expect investment here to slow down. It hasn't. In many cases, it's accelerated. While Artemis pushes toward a sustained human presence around the moon, NASA continues expanding the programs that study Earth's climate, monitor natural disasters, improve weather forecasting, and protect the planet from asteroid impacts. Those priorities have grown together, not at each other's expense. Then I started noticing something else. Closed-loop water systems, better robotics, remote medicine, satellite networks already supporting life on Earth. None of those technologies seemed interested in choosing one world over another. That's when I realized I might have been asking the wrong question. Maybe this was never a choice between saving Earth or exploring space. Maybe the two had been connected all along. Because if your real objective is protecting civilization, the first planet you strengthen is the one everyone already lives on. Which made me wonder, if this strategy is really about long-term survival, what kind of future are these institutions actually trying to protect? By this point, I realized I'd been asking the wrong question. Every source kept frustrating the same expectation. I kept looking for one defining catastrophe, one event that explained everything. It never appeared. Instead, every road seemed to converge on a different idea entirely. That idea shows up again and again in long-term risk research. The question isn't whether a catastrophe is likely. It's whether the consequences are acceptable if it happens. Those are two completely different ways of making decisions. We already make decisions this way. Buildings install fire alarms most will never use. Critical infrastructure prepares for failures everyone hopes never happen. Not because those failures are expected, because some consequences are unacceptable. That's when the pattern became impossible to ignore. Planetary defense, permanent lunar infrastructure, international cooperation, long-term space capability. None of them require the same threat. They only require the same conclusion. Some risks are simply too costly to ignore. And once you start planning around irreversible loss instead of likely events, the goal of space exploration begins to look very different. It stops being about discovering another world. It starts becoming about protecting the future of this one. There was still one assumption I couldn't let go of. If we're preparing to live beyond Earth, doesn't that mean we've already given up on Earth? It sounds like the obvious conclusion, but it isn't what the evidence shows. The same agencies investing in a sustained human presence around the moon are also expanding the missions that watch Earth's climate, monitor its oceans, track wildfires, study changing weather patterns, and defend the planet from asteroid impacts. Those programs aren't shrinking. They're growing alongside one another. That's when I realized I'd been thinking about this as an either-or decision. Protect Earth, or build beyond it. The institutions making these decisions don't seem to see that choice at all. They treat both as parts of the same long-term strategy. Because redundancy has never meant abandoning the original system. It means making sure the original system is never the only one. That's how engineers protect aircraft. It's how networks protect data. It's how critical infrastructure protects itself from catastrophic failure. Why would civilization be any different? The more I looked, the harder it became to believe that becoming multiplanetary was an escape plan. If anything, it looked like the opposite. The stronger the commitment to humanity's future beyond Earth, the stronger the commitment to protecting the only home we've ever had. Which left one final question. If all of this is really about preserving civilization, what exactly are we trying to preserve? By the end of this investigation, the missions themselves hadn't changed. What changed was the way I understood them. Across different agencies, different countries, different decades, the same principle kept reappearing. Build capabilities that last. Reduce single points of failure. Protect what cannot be replaced. Think beyond the next mission. Think beyond the next generation. That doesn't mean anyone knows Earth is doomed. It doesn't mean governments are secretly preparing to abandon the planet. The evidence never supports either claim. What it does suggest is something far more interesting. The longest-term planners increasingly behave as though depending on a single world is a risk worth reducing, even if that risk is never realized. Maybe that's the real story behind becoming a multi-planet civilization. Not escaping Earth, not chasing another flag to plant, but applying one of humanity's oldest engineering principles to humanity itself. Because responsible civilizations aren't defined by how far they can explore. They're defined by how well they prepare for a future they can never fully predict. Maybe that's the real shift happening in front of us. Humanity isn't racing toward another world because we've stopped believing in this one. We're learning that protecting the future doesn't always mean predicting what will happen. Sometimes it means making sure no single event can decide everything. Once I saw space through that lens, exploration stopped looking like an adventure. It looked like resilience made visible.